So what exactly is a tangent line to a curve? If we consider a simple curve like a circle to begin with, a tangent line is a line that intersects the circle in exactly one point. Any other line that intersects the circle has to intersect it in at least 2 points. So for a circle, we can define a tangent line to be a line which intersects the circle in exactly 1 point. However, that doesn't generalize very well, as we're going to see on the next slide. So here's the graph of a function. This turns out to be a cubic function, though that's not important here. The tangent line is the red line. The graph of our cubic function here is this curve, and the red line intersects the curve in 2 places. Whereas here's another line that intersects the curve in the same point, which intersects it only once. But that's not a tangent line at all. So what does make a tangent line? A tangent line is a line which just rests on the curve. It doesn't go through it. All right. If we were to zoom in, what we'd see is the more and more we zoom in, the better and better the agreement between the tangent line and the curve. All right. To see this maybe a little more dramatically, on the next slide, here's the same graph as before. We're going to take a piece of that and change our graphing window. So maybe something like this, and then graph it here. All right, same point. As we zoom in, we're going to repeat, zoom in some more, and finally zoom in some more. Right. The more and more we zoom in, the better the agreement between the red line, which is the tangent line, and the actual curve. Right. We might say that the graph of our function here, our curve, is locally linear, which means when we look close enough, it looks straight. Right? And the tangent line is the one that follows that straight. Any other line that intersects there, no matter how much we zoom in, it's going to continue to look like it has the same angle with the curve. It doesn't produce any better agreement even when we zoom in more and more. In the next example, we'll see how to go about finding the equation of that tangent line.